Okay, this is our second lesson on discrete functions. So we're going to be looking at arithmetic and geometric series. So as a warm up, this is a really neat video. You can search reason for math Gauss's addition and get like this just even the beginning of it to see the task that was placed on Carl Friedrich Gauss as a young 10-year-old in the 1700s as a bit of a punishment, not a punishment so much as abuse by a teacher, um, to add the numbers from 1 to 100. Now, back in that time, you actually had to write it on a slate and keep kind of track of like the numbers as you add them. And it's not impossible, but it would take a long, long time for students to do. So that was the point of it. Um, for us, if you can pause it, I want you to think about adding the numbers from 1 to 100. What might Gauss have done? You can think about it for some time. I'm going to spoil it, but if you pause it, you can wrap your head around how might this have happened, adding the numbers from 1 to 100. So the learning goal is we're using the formula for sum of an arithmetic and geometric series so that we can use it to solve problems. We're going to calculate the sum of arithmetic and geometric after finding the relevant information from the general term. So we'll look at the general term formula again to give us some help. So a series, where a sequence is just a list of numbers, a series is adding those numbers up. So it does have Sn. Sn isn't in the sequence because we're not adding them up. So it's just a representation of the formula. Instead of Tn, we have Sn because we want to add up all those numbers. So from 1 to 100, there's a couple ways to do it. And so what we actually think about is probably what Gauss did was he took the numbers and stacked them. And so if you had the numbers from 1 to 50, you kind of stacked 100 to 51 in reverse order, you notice what you get. And you ask the question, like, is it conceivable with this strategy? Could we possibly do it in our head or quickly? In the video, it describes Gauss as being done by the time shortly after he gave the instructions. After the teacher gave the instructions, he said this offhanded, there you go, and threw the slate on his desk. It's kind of a funny or really interesting story. But you ask yourself, using this strategy, could we have count them in our head? So if we add up all these, we get a whole bunch of 101s. How many 101s? You can see the numbers from 1 to 50, there's 50 101s. And so if you multiply 50 by 101, you actually get 5,050. And that's what it adds up to. We notice that this is the same thing, and so there's these kind of two methods. We're going to create a formula based on this as finding the average of 1 and 100. So if you add up 1 and 100 divided by 2, you get 50 and a half. And then multiplying by 100. And so we're allowed to do this because every number 1 to 100 is the same distance from 50 and a half, same distance from the middle. And so they really all cancel out, and it just ends up with 100 numbers at the center, which is 50.5. And that actually only works for an arithmetic series when we want to add them up. So it only works for linear terms. So a couple ways you can also think about this. Like Gauss's math would have been like a plus tn, so 101 times 50, so half of them. That's equivalent to this as well, and it's similar to like thinking the average, just where the 2 goes, just when you divide by 2. The average of 1 and 100 is 50.5, and then multiply that by 100. So it's debatable what method he used, but we can say that this is probably the strategy that he took. So find the sum from 1 to 96. We can see if it works as well. And you can do this also with smaller numbers, but you also could just add all the numbers from 1 to 96. Looking at the formula, though, you notice that you have A, you have Tn. You don't know how many terms there are. So you need to know that. And so what we do is we take out that old general term formula, A plus n minus 1 times D. We know term n is 96. We know the D is 5, and the first number is 1. The D is 5 because we're adding 5 each time. If you subtract 1 and divide by 5, you get n is 20. And then to use the formula, Now you can sub everything in. 20 times 1 plus 96 divided by 2. And so we get 20 times 97 over 2, which is 970.